The next lesson in the matter and energy unit is on Bohr models and valence electrons. You will learn TEK 8.5b. Identify that protons determine an element's identity and valence electrons determine its chemical properties, including reactivity. By the end of this lesson, you should be able to answer the following essential questions. What does the protons of an atom determine? What is a valence electron? What does the valence electrons of an atom determine? You remember the lesson before this one, you were introduced to the acronym APE-MAN. Remember, the APE stands for atomic number equals the number of protons equals the number of electrons. MAN stands for the mass number minus the atomic number equals the number of neutrons. This is how you would determine the number of subatomic particles in an atom. After determining the number of subatomic particles of an atom, you will be able to draw a Bohr model for that atom. In the nucleus, we have the protons and neutrons. And in the electron cloud is where you will find the electrons. Now, the electron cloud contains what we have here that are called energy levels. The first energy level, which is the level that's closest to the nucleus, can hold up to 2 electrons. The second energy level can hold up to 8 electrons. And the third energy level can hold up to 18 electrons. So remember, in the nucleus, you will have your protons and neutrons, and in your energy levels or the electron cloud is where you will place the electrons. So remember these numbers. First energy level holds up to 2. Second energy level holds up to 8. Third energy level holds up to 18. Now, let's draw the Bohr model for the atom carbon. Let's start with 8. The atomic number, which is located here, equals the number of protons equals the number of electrons. So the carbon atom has 6 protons, which are represented by blue circles. It also has 6 electrons, which are represented by black circles. Now we must determine the number of neutrons. We're going to take the mass number, which is this number, and we are going to round it to the nearest whole number. So 12.011 will simply become 12. Minus the atomic number, which is 6, will equal the number of neutrons. So it will be 12 minus 6 equals 6. And the neutrons will be represented by red circles. Also remember that the protons help determine the identity of the atom. Protons determine the identity of the atom. So we're going to place the electrons. The first energy level can hold up to 2. So we've placed 2 electrons. and we're going to place the remaining electrons, which is 4, into the second energy level, which can hold up to 8. And in the nucleus, we have 1, 2, 3, 4, 5, 6 protons and 1, 2, 3, 4, 5, 6 neutrons. And the electrons, we have placed 2 in the first energy level and the remaining 4 in the second energy level. Now, the electrons that are in the outermost energy level or outermost shell are called valence electrons. Valence electrons are the electrons on the outermost energy level, and these electrons determine the reactivity of the atom. So carbon has 1, 2, 3, 4 electrons in its outermost shell, so it has 4 valence electrons. Now, let's find carbon on the periodic table. Carbon is here. It is in group or column 14. The number below the group number, which is 4A, tells us the number of valence electrons that each atom in this group or column will have. So carbon, which is in group or column 14, has 4 valence electrons. Now let's look at the rest of the periodic table. There are a total of 18 groups or columns. Group 1 will have 1 valence electrons. As you see here, it says 1A. Group 2, all the atoms here will have 2 valence electrons. And we're going to skip this section in the middle. You will learn it in high school. And we will go to group 13, which will have 3 valence electrons. Group 14, 4 valence electrons. Group 15, 5 valence electrons. Group 16, 6 valence electrons. Group 17, 7 valence electrons. And group 18, with the exception of helium, all will have 8 valence electrons. Now, remember we told you that the valence electrons determine the atom's reactivity. So we're going to move from left to right. The left side of the periodic table, those atoms are most reactive and they have the least amount of valence electrons in their outermost shell. As we move to the right, the reactivity decreases or the atoms become less reactive. The most stable atoms are in the last group, group 18. They are non-reactive and they all, with the exception of helium, has 8 valence electrons. Now, let's review. What type of atom is this? First, we're going to look in the nucleus. You can see in the nucleus we have 1, 2, 3 protons, 1, 2, 3, 4 neutrons, and we have 1, 2, 3 electrons in the electron cloud. What atom is this? Remember, the number of protons tells you the atom's identity. So we know it has 3 protons, so we will locate the atom on the periodic table that has an atomic number of 3. This atom model has 3 protons, so it is a lithium atom. The number of protons determine the atom's identity. Also, if we looked at the periodic table, lithium is in group 1. And knowing that, along with that it has 1 electron in its outermost shell, how many valence electrons will it have? Lithium has one valence electron, so it will be very reactive.